Hello, welcome to Networking Field Day 14. We are here at the offices of Big Switch Networks. The presentation that you are about to see is attended by a group of invited delegates who represent the best and brightest minds in the networking industry. They will be offering comments, discussion, and their views on the technology of the company that you are about to see. If you'd like more information about this and other events, please go to our website at techfieldday.com or our YouTube channel at youtube.com/techfieldday.
So I'm Ganapathi Bhat, Technical Marketing Engineer for Big Switch Network. Today I'm going to talk about next big thing, that's containers, and how Big Switch is going to give a solution for container networking. As we all know, container ecosystem is growing, and we have seen it's rapidly growing, and we have quite a few options in terms of container orchestration, container runtime, and container cluster management, container application management. And from Big Switch perspective, being a next generation data center networking company, goal for us to provide fully automated, fully integrated, very easy to use, to manage, very easy to troubleshoot networking for containers as well. With that goal in mind, we have a solution for Kubernetes orchestration with Docker runtime. Today we are going to talk about and walk you through the demonstration of this particular integration we have with Kubernetes. So before going into the Kubernetes solution and demonstration, I want to level set on Big Cloud Fabric deployment option. On the left, you see the pFabric, Big Cloud Fabric pFabric. pFabric essentially the physical fabric. It's the leaf spine class fabric, which we just use for vCenter integration. And on the right, we have a P plus V fabric. Essentially, we provide virtual switch as well as part of this integration, as part of this deployment option. This primarily goes with the OpenStack and container integration we have. That means we manage both physical and virtual environment as a single entity. That's why it's called P plus V fabric. And for today's demonstration of container, I'm going to use P plus V fabric. That's why I wanted to bring this up front so that we have a clarity on how to deploy Big Cloud Fabric for the containers. Now let's look into the solution itself. The first thing, as I mentioned, we currently support integration with the Kubernetes orchestration. And this integration is based on container network interface. You may know about it, CNI interface. Given that it can be extended to other orchestration as well, the Mesos or OpenShift or other orchestration as well. Then the solution component perspective, if you look on the left, we have 3 components which goes with this particular integration. The first one is the virtual switch, which is a user space agent on a Linux, and we use the OVS kernel for a data path. And the second one is the BCF plugin itself, which goes on all the Kubernetes worker nodes, which provides the networking for the spawned containers. And the third one on top you see is the BCF container agent, which essentially sits on master nodes, Kubernetes master node, which talks to BCF controller for all configuration needs. And the benefit perspective, a single pane of glass, fabric config automation, and the visibility of the container networking in general. In the interest of time, I'm skipping some of the stuff. We'll directly go into the demo, as we have only 20 minutes. Again, the vPod concept applies here as well. You can deploy this Kubernetes cluster as part of existing Big Cloud Fabric alongside vCenter, virtual pod, or OpenStack virtual pod. Essentially, virtual pod provides the benefit of reusing your IPs, reusing your VLANs in the given Big Cloud Fabric. Any question?
So the key thing I think I picked up from the previous slide was that you're using Big Switch Lite, which is your operating system, as a vSwitch in the container host.
On a Linux host.
On a Linux host, yeah. So the host actually uses Switchlight OS as a virtual switch so that you can get the networking functions to the container?
Yeah, that's correct.
And so you program it just as if it's a physical, like your existing big, the controller, the big controller just manages as if it's like.
Yeah, it's just another switch for Big Cloud Fabric controller.
Right.
And we attach the container directly onto that virtual switch.
Right. But it's a virtual switch in the KVM host, which is the Switchlight OS that you're talking about here.
Yes.
Yeah, yeah.
That's correct.
Right.
Hope it's clear.
It is. I didn't want to go too. I just wanted to clarify that because I think that's a key point. Is it's the container networking is just the same networking as you've been using for the last 5 years.
Yeah, it's directly. I mean, containers are directly connected to the virtual switch.
Yep.
And Big Cloud Fabric controller manages entire fabric, including the virtual switch.
Greg, this is an area where, and I appreciate you bringing it up, because this is an area where if you're on the CLI, we're not going to show that today, but if you're on the CLI, this is an area where the vSwitch feels like a line card.
In that virtual chassis thing concept again.
And the leaf switch starts to melt into the backplane.
Yep.
So with that overview, I will jump onto the demo. So from the demo perspective, I am covering this entire integration in 3 parts. I'll walk you through first a deployment workflow. Essentially, first you need Big Cloud Fabric, physical fabric to deploy this particular integration. You can use the existing one and deploy it as a vPod. And the second thing is very straightforward. Again, you have to have a Kubernetes nodes which connects to the Big Cloud Fabric physical leaves. And you would install the Kubernetes cluster itself, all the Kubernetes components. Then finally, an important step is to glue it together, right? So you need to put in BCF integration components on worker nodes and the master node. As I said, there are 3 components here: virtual switch, BCF plugin, and the BCF agent. And we provide the Ansible playbook to deploy this so that it can be deployed faster, which we'll see as part of the demo. So I currently have vPods running on this particular Big Cloud Fabric. I have a Red Hat OpenStack virtual pod, as well as the vCenter virtual pod on this particular physical fabric. And I plan to deploy the Kubernetes virtual pod here. As you can see, we see both physical and virtual switches. Currently, I have 2 virtual switches for this OpenStack environment, which also uses virtual switch from the solution perspective. Then we'll add a new 3 Kubernetes nodes, and we'll see updated virtual switches here. On the right, I have a BCF controller CLI. I'm giving a show vSwitch command here. As you can see, I have only 2 virtual switches. And as we run this Ansible playbook, you would see additional virtual switches in real time. Before running Ansible script, you need to update some of the YAML file just to match with your environment. In this case, I have 3 nodes. Then you need to put in BCF controller information, credentials, IP, username, password, and the subnet you want to use for the containers, and the tenant you want to use it for containers. Then just run the script. It deploys all these integration components on all the nodes. And keep observing here. You would see additional 3 switches as we run this Ansible playbook. As you can see, it is identified by the name of the nodes, node 1, node 2, and the master node. This is auto-detected as part of this integration. And on the GUI as well, you would see the 3 new switches got added here. These are the existing 2 OpenStack switches, and these are the 3 new Kubernetes node virtual switches, which does the networking for containers as we go into this demonstration.
There's different vSwitches on purpose, or just because they're Kubernetes and OpenStack?
Yeah, it's kind of a separate virtual pod. I have wanted to demonstrate that you can deploy the OpenStack integration in one virtual pod, and I wanted to deploy the Kubernetes virtual pod. So that way, it's separate virtual switches managed by the Big Cloud Fabric.
No mixing?
No mixing.
Okay.
It's dedicated for all the programming done here is through our Neutron plugin, whereas all this programming done on the Kubernetes virtual switch is through our BCF agent sitting on Kubernetes master.
Good. That's fine. Thank you.
That's why it's kind of a virtual pod. You would have isolation between the orchestration. And you mouse over it, which we already saw it as part of the vCenter demo. If you click on it, it would give additional information on the vNICs, uplinks, and all those. Again, as part of this Ansible script, we created the virtual pod and the tenant for that particular Kubernetes workload. And we'll be hosting our application on this particular tenant. And this is the endpoint table. And we only have 3 endpoints. This is for control plane of Kubernetes nodes currently. And we deploy our containerized application, and we'll see this gets populated with the new endpoints. Any questions?
Is the first, what version of Docker are you supporting?
So currently, this setup has Kubernetes 1.4
Okay.
and the latest Docker
1.13?
Yeah, 1.11 or sorry, 1.11 I think.
1.11, okay. Is the kubelet speaking to Docker through the normal processes, and that's why you have the plugin in place?
Yeah, the Kubernetes part works same way. The way our plugin gets invoked is through the Kubernetes orchestration itself.
Okay.
When the containers are spawned, even our plugin gets invoked, and we'll go through that. We'll give IP address and the attachment point, all those things, which we'll see in the next part of the demo. Any other? You said
Nope, that's
multiple.
it.
Okay,
I'm good.
thank you. Sure.
There'll be more.
Sure. Okay, now let's look into the second part of the demo where we will deploy real application. I plan to use guestbook application here. As I was telling, when the Kubernetes master deploys this particular application, the BCF plugin will kick in, and it does 3 things. One is it gives the IP address to the container. Second, it attaches the container to the virtual switch. And the third thing is it programs the BCF controller, and the controller will program all the fabric switches, virtual switches for that container for networking. Again, this is the master node. We have 3 nodes, Kubernetes nodes, and these are the services output. Currently, we do not have any services. Services reflects as like application you have deployed. And I'm going to use namespace red for this particular application deployment. Namespace is nothing but, Kubernetes namespace is nothing but it's a virtual cluster within the Kubernetes so that you can deploy your application within that, so that you get isolation between the application if need be. And for us, the namespace is nothing but the segment on the BCF. So that way we provide the namespace level isolation on the fabric as well. Currently, there is no service or pods or containers exist. Once we deploy it, you would see some entries there as well. Now let's look into the demo, the guestbook application. And essentially, this has 3 microservices, we call it. First one is the front end. Essentially, it's served on port 80 and externally accessible through 10.10.15.15. Then we have a second service, which is a Redis master for the database to enter. Whenever you enter anything, it will go into this. And again, served on port 6379. And then we have Redis slave, which is the third service within this application. On top of these services, you need a replication controller so that you can scale up and down your application based on your business needs. I have a replication controller for front end with a replicas of 2. That means 2 containers will be spawned for this. Then again, similarly, Redis master has 2 replicas, and the Redis slave would have the same 2. And we'll play with these replicas as we go into the demo, and how BCF would provide the networking for those scaled up environments. Now, switching to BCF controller CLI here, again, we're just showing the show endpoint for this particular virtual pod. Currently, we have 3 endpoints, and let's run some Docker PS command here so that you can, in real time, you can see the containers getting spawned, endpoint getting added as we deploy our application. And a quick check on the services and pods. Again, there is nothing. We'll execute that command once we deploy our application. kubectl create and give the YAML file, and the namespace, in this case, is red. And look for this new endpoint and the containers on the right side of the screen. Now we just deployed it. As you see, additional endpoint got added here, and additional containers got added here. And from the services perspective, as per the YAML file, we have 3 services here and the 6 containers, 2 each for each of the services. Now looking back at the GUI, again you see 6 containers got added. And now we have a visibility into container. Essentially, we have a segment and the name of the container, IP and the MAC, and virtual switch and the virtual NIC information we have. We have visibility into the container here.
So it looks like you're standing up single container pods. How do you handle the visibility, or what's your story around using pods to run multiple containers and using the network namespace within that pod instead of going outside of the network namespace?
Yeah, I mean, essentially when you deploy application in a different namespace, in this case namespace blue, right? So we can just, it would be another endpoint in a different segment. If it is in the same Kubernetes virtual pod, it will be in the same tenant. If it is
Right, that you're talking about tenant namespaces within the network namespace. So let's say I create a pod with 2 containers in that pod. So instead of a single container pod, I have a 2 container pod. There's an IP address that's shared between those 2 containers at the network namespace. Do you provide visibility into that if I decide to use a single pod with 2 containers in it, let's say to use gRPC traffic between the 2?
So if the same IP is used between the 2 applications in the 2 different namespace, because we own the virtual switch, virtual NIC, we know how to differentiate, give isolation between those 2 virtual NICs. We can do that.
Okay.
Like the virtual pod can use reuse the IP, reuse the VLAN. Same concept applies here.
Yeah, I just wondered if there was visibility into the 2 containers that are running potentially inside
Within
that
the same pod?
Exactly. So we can take it offline.
Yeah. Okay, now just giving some additional commands to see what are the containers associated with each of the services. 2 containers each for each of the services. Now think that you want to scale up your environment, say like to 50 replicas. Just this is a kubectl command to scale because we have a replication controller. As you see, the 50 containers got spawned on the worker nodes. And from the networking perspective, the BCF plugin will provide the IP address, attachment point, and learn on the BigCloud Fabric dynamically, right? It's and when you scale up or scale down, we take care of the networking for you. Similarly, we are scaling up the Redis master as well. Again, the now total 100 containers we have, and everything is learned and programmed in the virtual switch as we spin up this the containers. Now let's scale it down just so that both sides it works. Scale it back to the original number, 2 replicas. Again, as you can see, only the 2 containers associated with it. It's terminating in the background, and it updates the BCF. Again, as you see, now back to the 6 containers. Now let's access the application itself, which is on 10.10.15.15 using the browser here. Open up a new tab, 10.10.15.15. Essentially, it is going to our corporate network to my lab setup, which is hosting this particular guestbook application. Again, it goes through the fabric, and services would take care of providing the front end. And the front end will talk to the Redis master. If you add any messages here, it would update that message in the database. And as a user, you would see any updated messages when any guest updates the entry in this particular application. So any question on this second part of the demo?
I think the key is here that you see the container as if it's directly connected to the network. So as a networking person, I see it as just another node or a virtual port, as though it's a physical port. The fact that it's virtual physical doesn't change the way that BCF operates.
Yeah, that's correct. I mean, you see it as one more endpoint, which happens to be a container in this case.
But the DevOps person or the container Kubernetes sees it as what they see.
Right.
It's not we're not changing the way you work, and I'm not changing the way I work.
Yes, and that's what my question was about how the pods are constructed, right?
Yeah.
And how many containers I'm running in a pod, and if I'm seeing those containers as individual entities versus seeing them as the single IP address that's assigned to the network namespace.
Right.
I got your question. I'll get back to you on that.
Okay, cool.
I got your question though.
Fantastic.
Yeah. So now let's look into, now we deployed application. How do you troubleshoot or monitor your networking for containers, right? I mean, we have used test path as part of vCenter. We'll extend that to this particular solution as well. In this case, you would have visibility into virtual switch and virtual NIC as well. That's the additional thing we would show as part of this. Then the fabric analytics, as Arkady mentioned, we have a dashboard for container networking. You would see all the historic view of all the networking events for the containers. And then finally, we have a fabric span to pull the traffic from anywhere in the network, anywhere in the fabric, to a tool which is connected anywhere in the fabric. So that way, some of the uniqueness of this fabric span, because everyone knows span in this room, because it's been used by any switch or any router, essentially to copy the production traffic onto a port which is connected to the tool, right? In our case, you can capture traffic on any edge interface and forward it. Copy of that traffic and forward it to the tool which is connected anywhere in the fabric. That way you do not have to move the tool to every switch if you have to debug anything, right? So that's one of the uniqueness here, and we have access to virtual switch and container to container traffic within the virtual switch across the fabric. We can capture that traffic and send it to the tool. And there is no replication of the traffic going into the tool, because in traditional network you would enable span on each of the switches. You would possibly get a duplicated traffic. Here, once we copy at the edge, that's it. We do not copy at every hop, so that way you would not get any duplicated traffic.
Edge is a VM as well as entry into the data center as well.
Yeah, I mean, whatever is connected to the fabric, we can
Same thing.
span
Okay, that's fine.
from to the tool anywhere. This is a test path view. I am just doing a reachability connectivity test for front end and the back end Redis master on port 6379. This is the database port I have for TCP. As you see on the report, at every hop, because these nodes are on different rack, that's why it will cross the spine. At every hop, you would see the virtual NIC information, which is received, which is connected to the container. This is the uplink port. And the hop 1, which is a physical leaf, you would see Ethernet 2 and Ethernet 49. Again, this is based on real hashing in the hardware or virtual switch. If the flow changes, it would be different. It could be different because the hashing can change based on your flow parameters. So we give exactly during the test window what port is used for that particular flow. Similarly, for all the hop, you get enough information. As Arkady was telling, we have counters as well to debug it further. Now let's look at the fabric analytics. Essentially, again, we have an additional dashboard which collects all the networking events for the container networking. You can go back in time, zoom into this report, and you can click on any of the particular event of interest. Then you can click on it. It would give additional information. Again, as you can see, we have all the information about the virtual switch, virtual NIC, where it is hosted, all those things.
So is this an additional software platform that we need to deploy?
No,
Some type of collector for the analytics?
No, it's built into our BCF controller.
Okay.
You can use it even for the regular monitoring of your traffic for any logs, any stats. And this just adds one more dashboard for container networking as well as the vCenter networking, as we saw earlier.
Okay.
It's built into your controller. You do not have to pay anything or host any additional software outside of BCF controller.
Okay.
The fabric span is the feature. We just you go to the visibility span. We'll span all the TCP traffic specific to this application on all the edge, and we'll send it to the Wireshark tool, which is connected on Ethernet 40 on rack 2. Good thing is you can provide a filter at granular as IP TCP port, and this is the port where I have Wireshark, and this is currently not active. We'll activate this particular policy or a span session, and we'll bring in the Wireshark as well as part of the screen here. Currently, we don't have anything. We'll just activate this particular policy. Now, we would get all the application traffic from the virtual switches to this Wireshark. And these are the keep alive mechanism. We have Redis master and slave. 3.5 is master and 3.6 is slave. Once you apply it, you would get all the statistics on the BCF controller as well, how many packets have been copied to the Wireshark or the tool. Now, let's access the guestbook application so that front end accesses the Redis master, right? Now, we're just refreshing it. As you can see, the green ones are HTTP requests coming from outside, and these red ones are 3.2 to 3.5, essentially the front end to back end access just to see whether any messages for the guest. So this is how you can troubleshoot and monitor your container networking. That's what I had. Any questions? Other than the one, I will answer it.
All right, thanks.
You can ask any question but that one.
Just one quick one. CNM, I think I had Mesos and Mesosphere, DCOS, and Docker up top. Support for that coming?
No, we do support that. It's more of experimental stage.
Okay.
But we have some code around it. Yeah.
Fantastic. Thank you.
It should work.
Okay.